I am a huge Terraform fan.
Yeah, it's such a great tool.
It is, it is. Alrighty, we will go ahead and get kicked off here. Welcome to our webinar of the evening, Deploying a Web App with AWS ECS and Terraform. We have the lovely guest, Mariia Kerimova, to present a hands-on workshop for us tonight. Before we get into the meat of tonight's content, just a quick little background about Women Who Code and this organization. My slides will advance to the next slide. First and foremost, hello, my name is Bree. I am a senior software engineer at Capital One and one of the 2020 Leadership Fellows for Women Who Code. I co-lead with my other leadership fellow, the Python and Cloud tracks. And if you have any questions about getting involved, the material you find today, you can reach us at cloud@womenwhocode.com. And that will also be on a slide, so don't fret about writing that down or memorizing it. For those who are new to Women Who Code, welcome. And for those who are familiar with us, welcome back. Just as a quick reminder, Women Who Code's mission is aimed at inspiring women to excel in their technology careers. We see a world and a vision where women are representative across the technology landscape as executives and founders and board members and scrum masters and of course software engineers. Our target audience for all of the events that we hold are engineers with 2 or more years of experience looking for support and growth in their career development. For all of our amazing events that we hold and all of the digital spaces that we occupy, our code of conduct is always in play. And essentially, you can read this at womenwhocode.com/code of conduct, but to sum it up, Women Who Code is an inclusive community that is welcoming of anyone who's here to inspire women to excel in their technology careers. And we will not tolerate any harassment of any members in any form. If you experience, a situation or witness a situation, hopefully you don't because this is an amazing community. But if you do, you can fill out a code of conduct report form at that same link, womenwhocode.com/code of conduct. A little bit of the good stuff, staying connected. If you love what we did today, if you have questions, if you want to see more, if you want to get involved, here are some ways that you can connect with us. We are on Twitter and Instagram at WWCode Cloud. We also, you can join our movement, our organization, this track at womenwhocode.com/cloud. As I mentioned before, you can email myself and Archana, the 2020 Leadership Fellows leading this track, at cloud@womenwhocode.com. And then all of these events, including today's webinar and workshop, are available on the Women Who Code YouTube channel. And finally, you can find us in Slack. If you are not already a member, feel free to email us and we will get you the link to Slack. That is where all of our community members are having amazing conversations about life and books we're reading and new technologies we're finding. And all of these platforms will also help keep you in the know of our upcoming events that we have planned. And we got quite a few good ones. So without further ado, I'll stop talking and get to the meat that we've all been waiting for. Mariia Kerimova, DevOps engineer who is based in New York, worked for Trek 10 and is really passionate about cloud computing and machine learning. And we're so thrilled to have her here presenting with us today. So Mariia, I'll let you take it away. I'll stop sharing my screen. And the floor is all yours.
Thank you. Okay. Can you see my screen? Okay. Yeah. Okay. So hello everyone, and I'm really happy to see you and to give this presentation. And also, thanks for joining, and Bree for setting up this event. And so today I want to talk and tell you about Terraform, ECS, and GitHub Actions. This is a very modern and popular technologies. We will deploy a simple web application written in React, and I will give you a brief description of each service that we will use, and we will see how it works in action. So let's start with Terraform. So first, Terraform is open source infrastructure as a code tool. It was released in July 2014, and it's written in Go. Main purpose of this tool is provision infrastructure. So what does it mean? So basically, instead of creating resources by clicking in the web browser or using CLI tool in an imperative way, you write Terraform files where you define what resources you want to create, and then just with a few commands, you let Terraform to create, destroy your resources in declarative way. And Terraform supports a lot of cloud providers, GCP, Azure, AWS, IBM. And actually, if you know programming language Go, you can write your own provider. So as I mentioned, we will deploy a web application using ECS and Terraform. For this, I created already some Terraform files for creating the infrastructure. And also Allison, she wrote a simple web application using React. And I will drop in the channel the links. And you can follow along or look at them later. It's totally up to you. So I will go to my repository. And we will look at the, first we will start with a web application. So I will run the command yarn start. And what it will do, we will see our web application in development mode on my laptop.
Hey, Maria, sorry to interrupt. Yeah. Can you make your screen just a smidgen bigger for us?
Oh, I'm so sorry. Yes.
No worries. Oh, beautiful.
Yes, it's awesome. I just this morning I saw her article and she posted in Slack Women Who Code general channel. So and it was awesome. So basically you can use it like a coloring book. Okay, so what we are doing here, we are running this application in development mode on our computer. So right now, imagine that you want to build application and run it in a container. In this case, you can use Docker. So let's recall that images are created, that containers created from images, and images created from Docker file, which is a plain text file that specifies all the components you want to include in your container. And I wrote a simple Docker file, and it's a multi-stage. First stage, we use Node as a base image. And then we use another stage, Nginx web server. So to build image, you run the command docker build, and I will use tag workshop latest. So you run this command, and it will you will see stages, and then you will see output that successfully built the image. For someone who is following along, it may take a little bit more time. And while it's building, let's talk about Docker. So, as you know, Docker uses client-server architecture. So Docker client talks to Docker daemon. Sometimes it's called Docker D. And Docker D listens for API requests and manages Docker objects like containers, images, networks, and volumes. And registry, it's like a repository for your images. So you can store your images in registry, and probably you've heard about Docker Hub, where you can store public images. But as it public, of course, you don't want sometimes to post your images on public repository in Docker Hub registry. So in our case, we will create our private registry. And for creating private registry, you will use AWS ECR service. So I will go to my web console, and we will go to the service Elastic Container Registry. We will go to you will go to ECR, and then you will create the repository. In my case, I will call it workshop. You can also enable tag immutability or scan and push. But for now, we will just create a repository. Okay. So go to your repository, and then you can see AWS gives us instruction how to push our image to this private repository. So you see a few push commands, and the first command will give us authentication token, and it will log in me to this repo. After this, the second step, it says build your image. We already built our image, and we will skip this step. But after that, you can tag your image. And after that, you can run Docker push and your image. So after all steps will be complete, we will be able to see our image in our repository workshop. Let's refresh. Awesome. So we have our image in repository. And after this, we can go to the next step, which will be right now we can go to next step, which is provisioning infrastructure. And I decided to create the following infrastructure. It will consist of virtual private cloud with 3 public subnets in 3 availability zones. It will have Elastic Container Service and also application load balancer. So now you can go to repository for Terraform, It's called ECS Terraform. And you can see Terraform files. In each file, I defined resources I want to build for my infrastructure. For example, ALB, it stands for Application Load Balancer. And there are also auto-scaling group, IAM rules, VPC. And actually, you can find README and read about each file and what resources I want to create.
Hey, Mariia.
Yep.
Can you make that a little bit bigger if you, yes.
Oh my.
And then if you make the font just a smidgen bigger.
Okay. Oh, okay. Sorry.
If you do you have a Mac?
Yeah.
Oh, perfect.
Yeah.
There you go.
Okay. So just quickly repeat myself that application load balancer is in ALB file, auto-scaling group is in ASG. There are also other files, but in general, you can find every description in the README file. Okay. So now I want to start provisioning my infrastructure. So what are steps? And there are following steps. First, you need to run the command terraform init. So this command will initialize your working directory containing Terraform configuration files. This is the first command you should run every time, like when you wrote configuration files or you cloned repo, and it's safe to run this command multiple times. So after you initialize your working directory, you run the command terraform plan. So terraform plan creates execution plan. It will output what resources it will create. As you can see here, it asks us for variables. And there is a file called variables. And I created two variables, key name and cluster name. Cluster name, we will discuss it later, but briefly, it's like a group of your resources. And in our case, it will be EC2 instances, tasks, but you can choose any name you want. Key name, it's a key name of key pair. It's SSH keys. And if you don't have these keys, you can go to EC2 service and at least okay. After this, you can go to key pairs, and you see I created already key pair, and you can just click create key pair, and it will and enter name, any name you want. Just don't forget it. And just to remind, key pair SSH keys, it's like a set of private and public keys, and they you use them as security credentials. For example, instead of using user name and password, you provide SSH key to prove your identity. Okay. Let's come back to our Terraform. And let's continue. So for my cluster name, I will name my cluster ECS Workshop Cluster. And for my key name, I already created ECS Workshop. Yeah. Okay. So this, as I said, Terraform plan will output all resources it will create for our infrastructure. Okay, so as you can see, we plan to create 25 resources. A plan command will not create these resources yet. For creating the resources, you need to run the command Terraform apply. And it will ask you again the name of the cluster, and I will double cluster. And for keeper ECS workshop. Okay, awesome. It will ask us one more question. If we agree to execution plan, and I say yes. And it will start creating resources. And it will take maybe 1 to 2 minutes, no, 2 to 3 minutes. And while it's creating resources, I want to continue the presentation and tell you about ECS. So what is ECS? Elastic Container Service. It's a service that highly scalable, fast. It's container management service that makes easy to run and test and manage Docker containers on a cluster. And it's a really great service for application, for microservices architectures, for batch processing, for machine learning, and hybrid apps. There are 2 main types of launching your containers. Unmanaged and managed, and they called also EC2 launch type, and Fargate accordingly. So what's the difference? So if you want to have control over your instances and over your cluster, and to manage yourself what kind of instance I want, T2 micro or M3, where you want to create auto-scaling groups yourself, you use EC2 launch type. But AWS also provides you another option, and this service called Fargate, and it allows you, AWS will manage your cluster. So you create, you don't need to create auto-scaling group. Fargate will do it for you. In my example, I decided to go with EC2 launch type. So basically, I decided to what kind of instances I want, and in our case, we will have T2 micro, and I defined auto-scaling group. Okay, and before we will go deeper, we will discuss main components of ECS. So first, it's image, and we already know that image built from Docker file, and that Docker file describes all components we need for our application. Then you need to create task definition. So what is task definition? It's a JSON file that describes one or more containers, but up to 10. And you need to provide parameters such as Docker image, CPU and memory for which task or container, also launch type, networking mode, login configuration, and IAM roles. So after this is task definition, and then the main component is also cluster. So cluster is a set of resources, and in our case, it will be EC2 instances, right, of T2 microtype. And what also main point of EC2 instances in the cluster, every instance has to have container agent installed. And it's very important because container agent allows you to attach your instance to the cluster. How can you install a container agent? You can do it in multiple ways. You can SSH to your instance and to install Docker and container agent. And also you can use ECS optimized AMIs that have already Docker and container agent installed. It's actually what we will use in what I wrote in our Terraform files. We will choose ECS optimized AMI. Another main component is service, and the service enables you to run and maintain the specified number of tasks in the cluster. And in our Terraform, for example, I specified that I want desired count, so desired number of tasks in our cluster 10. So basically, each task in our case will have one container. So we will have 10 containers in our cluster. Okay, and also I defined load balancer. We will talk about it later. And service enables you to maintain this number of tasks. And if task will fail for any reason, service scheduler will help you to launch the instance, the task, sorry. Capacity provider. So capacity provider enables you to manage the infrastructure. So as I mentioned, I decided to go with EC2 launch type, and I created autoscaling group. And capacity provider uses this autoscaling group to manage number of EC2 instances in the cluster. So for example, right now I have 3 instances, but if my traffic will increase, it will autoscale my instances, but I stop only to 4 instances. And one more point that it's important to enable manage termination protection and managed scaling. For example, when managed termination protection enabled, ECS will prevent EC2 instances that contain tasks to scale in. For example, if you cluster If instance will have one task, it will prevent from scale in while this instance has task. Okay, and also one more point that for using cluster auto-scaling, you also need to provide a service linked role. And I defined this in Terraform files. You will see later in AMI TF file. Okay, and a few more points about ECS that about networking mode. So AWS provides us 4 options. As you see, non-breach, host, and AWS VPC. What a difference. So none will not have any external connectivity. Breach, which is default mode, will use, as you know, so Docker has a virtual network, and breach uses this Docker virtual network, which runs inside every container instance. And host mode bypasses Docker network, a virtual network, and it maps container port directly to EC2 port. So, and one more, AWS VPC. Every task is allocated Elastic Network interface. So you must specify its network configuration when you create service. And also, if you use Fargate launch type, you are required to use AWS VPC network mode. Okay, and I think this is the last one. Main component is log configuration. So by default, containers, they use the same login driver as Docker daemon uses, right? And you may use login driver other than Docker daemon, but you need to specify login driver. And AWS provides a lot of options. It's Splunk, FluentD, a lot of different ones. But in our case, we will use AWS logs. And in this case, it will create a CloudWatch log group and will send all logs from our application to this log group in the CloudWatch service. And we will see it later too. Okay. And one more point, as you remember, in service, I specified a load balancer. And I decided to use load balancer. And in this example, we will use application load balancer, but just for general information, you can, there are like 3 types of load balancers in AWS: and application, network, classic. But application load balancer supports path-based routing, and it works on application layer of OSI. And also it supports dynamic host mapping, which is, for example, if your tasks container, if your task container definition specifies port 80 for Nginx web server, and port 00 for host port, then host port will be dynamically chosen from ephemeral port range. So this is about ECS. And oh, okay, awesome. So as you can see, Terraform already created all resources for us. And also I defined output in our output file. And also you can see the DNS of our application load balancer. And if you will copy this DNS and you will go to your browser, what's going on? Okay. You will see our application running on AWS using ECS service. So it's awesome, but now let's double check. Let's look at our ECS. Go to Elastic Container Service. And as you can see, the cluster was created. Now we have one web service, and we have 10 tasks. So if you go to any task, for example, here, let's go, and you will see the external link. And this is ephemeral port from our host. And I enabled so you can see. So this is one instance of our task definition running in container. Which is awesome. Let's go and see ECS instances. And right now we have 4 instances and capacity provider, which is our auto-scaling group. This is our auto-scaling group. And one more thing is CloudWatch. So as I said, we use logs, and for log driver, we specified AWS logs, which will create a log group. Oh, I have some billing alarms. So we see that it created ECS frontend container log group, and now all my logs displayed in CloudWatch right now. And here are logs. Okay. So as you can see, this is our auto-scaling group, and desired capacities 4, but we can reduce to 0. And also we now can terminate our instances. And then we can tell Terraform to destroy our instances and all our infrastructure. And we can do it by running the command Terraform destroy. And it will ask us again the name of the cluster, which is ECS workshop cluster. And my key name ECS workshop. And then it will give us the list of resources it will destroy. and it's 25 resources, and it will ask us if we want to do it. And yes, I intend to destroy my resources. And while it will destroy our resources, I will continue with presentation, and we will talk about GitHub Actions. So GitHub Actions, this is a tool that will help us create CI/CD pipelines, and so which means we can build, test, deploy our applications faster and more reliable way. And it's like Jenkins or GitLab. You write your YAML files to define your workflow, and you can create tasks. They're called actions, but there are actually a lot of actions built already by community, and you can find them in GitHub Actions marketplace, which is actual screenshot from here. And Terraform provides their actions where you can initialize and test and validate your configuration files, your Terraform files. So, but before we will see it, I want to tell you a bit about how it looks like. So this is this is GitHub Actions YAML file where you specify jobs. Before I will tell you about jobs, so there are some core components we need to discuss. The first is action, which is small building blocks of workflow. Runner is basically a machine where you run your GitHub Actions. And I use GitHub Actions Runner applications, but you can do it on your machine, which is called self-hosted runners. Job is a set of steps. You can define dependency rules, like how your job run in workflow files. Then steps. This is individual tasks or run commands. Workflow file, we just saw a screenshot of YAML file that defines the workflow. And event, it's basically an event that triggers the workflow, and it can be push commands to the master branch, or it can be pull request event. Let me go again to Terraform repository. And as you can see, I have a directory .github workflows. And in these directories, I have a file, CI Terraform. And in this file, I define my events in this section. So I want to trigger workflow when I push to master, or when I do pull request. I have only one job called Terraform, which runs on Ubuntu latest on GitHub Runner. Then I have a couple steps. The first, I check out. This is one of the most common step you do. You check out from your master branch, and then I set up Terraform. Here, I initialize my working directory, and I use also I need to provide some my secrets as AWS key and secret access key. After that, I check if my configuration files are okay, and but just by running Terraform validate command. And then I plan my resources. Also notice here, I ask if the event name is pull request. On pull request, I want to create a comment which says the output if my validate command was successful. And here I commented, but it's a command Terraform apply. If it's master branch and event name is push, I apply and I create my resource, my environment. Okay. So thank you very much for your patience and listening to me. And I know that I covered a lot, and probably you want to play on your own with all these tools. And if you want, you can use the Terraform repo and React application to play with this tools. And if you will stuck on any step, you can reach out to me. This is my email. Also, I'm on almost all channels and Slack for women who code. There are also some resources I used, but basically it's documentation for ECS and for Docker, and GitHub Actions has good documentation, and Terraform too. So that's it.
Awesome. Thank you so much, Mariia. That was fabulous. We have a little bit of time to pick your brain. For anyone who has questions, feel free to throw them in the chat. There are a couple that I was able to get answered. Ramya asked, where is the app source code written? That is in one of those links that you shared, correct?
Yes. I can send them one more time. Or actually, I also mentioned them in presentation. So if you want, I can say that I can give presentation and you can go from the link in presentation.
Perfect.
Mm-hmm.
Any other questions? Let's see, we got a new one. We got some thumbs up, some thank yous. This is fantastic.
Thanks so much.
What a great walkthrough. How are secrets stored in AWS is a question from Amy. This is a very packed question.
Yes. So let me show you. There are a couple services, Secret Manager, so System Manager, and so okay, I will not show you, but there are a couple of resources you can use. Parameter store for it's here. For creating your secrets and saving them. For example, I'm not sharing. 1 second. So this is the AWS System Manager parameter store where you can store your secrets. Yeah, that's it.
Someone asked that ECS is good for long-running apps, but what if you need the app to run only once? Do you have any recommendations there?
Yeah, so you use service for running long-time applications, but you can actually use just run once after you created your task definition, you run task only once, and you can do it like in a web console. You can use run task command, and it will run only once. Yeah, it's very common, like for batch processing, or just it's not only for a long time. Mm-hmm.
And then there are other, you can consider Lambda or Kronos is a good tool to run Docker containers in a cron schedule. So Jocelyn says, this was great. One question, in your experience, what is the best IOC tool for use in AWS, Terraform or CloudFormation? Oh, the great debate. I love this question. I would love to hear your opinion though.
It's so difficult. I would say that I would go with Terraform. I like Terraform. I'm biased a little bit. I think I like a lot of cloud providers, and I use Terraform. An advantage of Terraform that you can use it in for every cloud provider, which is great. But if you use only AWS and you are more comfortable with CloudFormation, it's also a great tool. Any declarative way of creating resources, I think, is awesome.
Fabulous answer. Let's see, any more questions? April asked Ansible versus Terraform.
To be honest, I can't answer this question because I'm not good with Ansible. I'm just starting. So
I have it in my past. I've used Ansible and Terraform, and I usually use Ansible for configuration management. So when your servers are provisioned, how do I install and configure all the tools on the box? Because I don't know the proof behind this statement, but Terraform's APIs for interacting with the AWS interface to provision your infrastructure, like the EC2 instances and the databases, are a little bit more resilient and tried, true, and tested. So I keep building my infrastructure with Terraform and then the configuration with Ansible, because I do love Ansible. I highly recommend anybody.
Yeah, but it's great that you can combine for provisioning infrastructure Terraform, and for configuration management, it's Ansible. Yeah, it's great.
All right, we have one more question. Curious what the thoughts are on using the managed Kubernetes service from AWS instead of ECS. Seems like ECS may be a smaller learning curve to getting started quickly, but Kubernetes would be cloud agnostic. Curious on your opinion.
Yeah, I was expecting for this question. When I was learning ECS, I always was thinking about like Kubernetes, because tasks, pods, and a lot of things. But I think ECS, it's a bit simpler than Kubernetes. But it's kind of like a question of what would you choose, orchestrating your containers with Kubernetes or ECS. I don't know. It's I would think that you can use again Kubernetes with different cloud providers, right? And it's awesome. If you know how to manage it in Kubernetes, you will definitely be able to manage your containers in AWS and using ECS.
It goes back to that trade-off of time and the learning curve that you want to take to how much you need flexibility in the tools that you use. So it's all situational, right?
Yeah.
Awesome. All right, well, I will wrap us up really quickly. Thank you again, Mariia. This was fabulous. Loved hearing this presentation and your insight on these technologies. was really eye-opening and inspiring. So let me share
so much.
Hopefully you can see that. As a reminder, ways to stay connected: social media, Instagram, Twitter. Join us, join this movement at womenwhocode.com in our cloud track. There are also 5 other tracks that I highly encourage everyone to poke around with. They're also providing some really phenomenal content digitally. And then you can email us at cloud@womenwhocode.com, and this amazing talk will be available so that you can follow along, pause, stop, do what you need at our YouTube channel at Women Who Code, YouTube space, not womenwhocode.com, but you get the gist. And then for those who were on the chat today, you should have a link to our Slack channel. Stay tuned for some upcoming events. Our track has quite a few planned. On July 22nd, we are going to get into event-driven architecture and Kafka, how that enables that paradigm. On July 25th, we have Cloud Day. There's 4 speakers lined up, to one teeing off the conversation about why the cloud is so important, how you can utilize it, and then 3 other speakers talking about AWS, Azure, and GCP and the different features that are provided within them. And really awesome part about this event is that 3 of those talks will be presented in Spanish. On August 19th, we have Data Mesh and Data Product by Example coming up. And then coming soon, we have a VMware event, an event by LinkedIn about how to create your own online course content. We were tossing around some more ideas about Containers 101, getting AWS certified. We had a fireside chat about that, but this will go into building that study group around there. So there are lots of amazing events coming up in this space. So mark your calendars and stay tuned and stay plugged in. And with that, I thank you, Mariia. I thank you all for attending. And for those who watch in the future, we hope you had a phenomenal event, and we will sign off for the evening.
Thank you so much.
Of course. Let's see. I now need to figure out how to stop the video. A fun part. All right, goodbye, everyone.
Oh my God. Oh my God. I just reading all the messages because I didn't look at any
I will leave it
chat.
on to you to read just a little bit. You did a phenomenal job.
Oh,
Lots of good questions. Hopefully, I think I got almost all of them. So let's see. Yep, all of the questions. And I can get a copy of this chat and send it to you. So.
Oh, thank you. Yeah,
of course.
My sister. Okay, thank you very much, Bree, for setting up. Yeah, now I will enjoy my meal. Okay, thank you so much for setting up one more time. And let's stay in touch.
Of course, if you have any talks or you figure out how you want to get involved, we are happy to partner with you and provide a platform for you to continue speaking. And
yeah, it would be great. Yeah. Actually, it's interesting that we had a question about Kubernetes because I actually want to get certified. I need it. Yeah, so maybe I will give a talk about this after all stuff.
Love it. You can do a comparison. Actually, I'll ping you because I got some events noodling in the background, and I'd love to bring you in on them.
Awesome. Okay. See you. Talk to you soon.
Have a good night, Mariia.
Yeah. Bye.
Bye.